Hey guys, it's your pal Dave from notesandvolts.com, and here we are, part 11 of the Teensy-Synth project. Now technically we finished this project in the last version where we created the hardware and I gave you a schematic that should be all you need to actually build your own version of this. But if you know me and this channel, you know the project isn't truly finished until I build a cool custom enclosure and stamp my name on it. Now, before I show you what I've done, I just want to throw in a little disclaimer. I created this channel to allow me to build cool stuff using all the tools and skills that I have available at the moment. But one of the criticisms I get is people say, well, that's really great, but I don't have all the tools and equipment you have. How am I supposed to do this? And the answer is you don't need to. You don't need to go through all the steps I'm going to go through to enjoy this project. So you can build it on a perf board, you could build it on a permaproto, whatever you want. You can stick it in Tupperware, you can put it in a cardboard box and wire the pots directly to the board. And people have been sending me pictures of themselves doing this and the versions they're coming up with, and it's really cool. And just make sure if you make a version of this, send it to me. I'd really love to see it. Just to show you how my enclosure skills have improved over the years, here's a project I made a number of years ago in a brownie pan. And this actually went on tour with a drummer friend of mine, and it works. It's not pretty, but it did work. Okay, with all that out of the way, let's take a look at what I came up with. So here it is, the Teensy-Synth hardware version. Now, if you take a close look, you can see the potentiometers and switches that I showed you in the schematic in the last episode. And here are the switches I used. I wanted something kind of very sturdy and industrial looking, so I used these toggle switches, some nice potentiometers, and some cool looking knobs. And there it is. I think it came out really great. On the back, you can see I have a DC power jack, I have a 1/4-inch audio in, I have a 5-pin MIDI jack, and our big beefy USB jack. So when I made this project, I figured I needed a circuit board to make it all fit. So this is what I came up with. Here is the circuit board. And you notice it's kind of a strange shape, and that's just to make it fit around all the jacks inside the enclosure, and we'll take a look at that in a sec. And another thing to notice is that I had to use a surface mount component for the multiplexer. And if you remember from the last video, I mentioned I could not find any sources for the old dip packages for that particular unit. So here is the surface mount footprint I ended up using. So let's open this up and take a look at the inside. So here's the board, and you can see that cutout shape allowed me to board mount this USB jack and use panel mounts for all the other jacks. So I had to cut little spaces so they would all fit properly. If we kind of look at some of the components, here's the power jack coming into this area here. This is the power regulation circuit. This is the optocoupler for the MIDI jack, and you can see the MIDI jack feeds right into there. And here's the main Teensy board and audio board. Now, one thing I wanted to make sure is that I use that whole assembly that we've been using throughout this project. So I didn't want to have to take it apart to use it on this board. So here it is. It actually fits right on the board just as we made it in the previous episodes. And one more thing to notice, the toggle switches are actually not board mounted. Now, I was looking around for a nice board mounted toggle switch and I could not find them at a decent price. So what I figured is I would check on Amazon and find some cheaper toggle switches and mount them directly to the enclosure. And for this one, since it's kind of sitting right in the middle of the board, I actually had to make a little cutout in the board to allow it to fit. And that way I could use some cheaper, easier to find toggle switches and not be too concerned about the exact part number. Another thing to notice is that the audio jack that we've been using throughout this project to get the audio line out, I'm not using anymore. So I'm actually taking the audio from this area here. So these two holes here are line outs for the audio, and all I'm doing is taking two wires and running it directly to my 1/4 inch audio jack. And you can see when I insert a cable, I made sure that there was room and the board didn't interfere with it. Like I said at the beginning, this was actually quite a challenging build. And because I'm using a circuit board, all the parts have to line up very precisely. Now, I do have a milling machine that allows me to very accurately drill out these parts. So doing this without it would be a challenge. Also challenging is the cutout for the USB jack. You notice it's a square cutout. And I do this by plunging the milling bit in and then just basically drawing a square shape with the X and Y axis. But doing that freehand would be quite interesting. So to help kind of make this a little easier, I am working on a 3D printable version of this enclosure that will take the place of this Hammond 1590 DD box that I used. And I think that's going to make it a lot easier to accurately get all these hole locations and cutouts. So I'll give you an update when I figure that out. Now, I've also had some people inquiring already if these boards will be available. And that's something I'm working on. I have never really sold anything like this online before, so there's some logistics I have to work out. But I'm trying to make a few of these available if you're interested. You can contact me on one of these social media accounts and I'll try to work something out. So there you go, guys. That's what I came up with. I was filming during the entire build process, and I also did a lot of it live on my Twitch channel. So I'll put all that footage together and let's just watch a condensed version of all the steps I went through to build this project. So as you may know, every electronic project starts off with a schematic. And I draw my schematics using KiCad, which is a free open source schematic capture and circuit board design software package. This is the schematic for the Teensy-Synth that we outlined in the previous part of this series. If you haven't watched that yet, make sure you go back and watch it because I go through this in greater detail. Now that we have our schematic, we can start thinking of our circuit board design and the look of our overall enclosure. To start off every project, I try to model it the best I can in Fusion 360. A lot of the times you can get free models for your components from electronic resellers like Mouser and DigiKey. I downloaded this model of a Hammond 1590 DD enclosure right from the Mouser website. Next, I'll get representations of the various components I'm going to use. If there isn't a model available, I'll take some rough measurements and make a crude model that just acts as a stand-in. You can see the audio jack is one of these types of models. Once the parts are in place, I'll make a rough outline of the board shape I want, and I can check for all the clearances with the 3D model. This will also let me lay out the potentiometer and switch locations and make sure it not only fits, but it looks good. Once I'm happy with the design, I'll go back to KiCad and draw the outline of the board and place the components exactly as they were in the 3D model. The potentiometers and switches in this project need to be in exact locations because they need to match our enclosure. Once I have these in place, I know how much room I have for the other components and I can place and route them accordingly. Once that's done, I can check out the board in 3D and see what the final product will look like. Once the board is finalized, I'll import it back into Fusion 360 and make sure it still fits, there's no clearance issues, and everything looks good. Okay, I think everything looks good, so I can send the board out to be manufactured, and when it comes back, we can start assembly. To start the assembly, I decided to install the surface mount multiplexer chip. Normally I just use my soldering iron to do surface mount chips, but I got a new hot air gun and I wanted to try it out. So to do this, I used my tweezers, a syringe of soldering paste, and my hot air gun. So after cleaning the board with some flux, I used the syringe to lay down 2 lines of soldering paste. What I discovered was that the tip of the syringe was a little too large and I could have used about half the amount of paste that I did. Next, I used the tweezers to put the chip in place and line the pins up. Next, I used the hot air gun to flow the soldering paste. There were a couple of bridges, so I used some solder wick to clean that up and then reflowed the pins with the soldering iron. Now it's time to work on the Teensy board assembly. I need to attach 2 wires to the D+ and D- pins for the external USB port, so I started by tinning them with a small amount of solder. Next, I tin the ends of 2 pieces of stranded wire and then just reflow the joints with the soldering iron. Now I could trim the ends of the wires so they would fit into the D+ and D- pads on my circuit board. Next, I soldered 2 pieces of stranded wire to the ports marked L and G, which is left and ground, on the audio out port. These would go to my external audio jack. Now it was time to install the Teensy board on the circuit board. I placed it in the socket, making sure the 2 wires went into the D+ and D- pad to transfer the USB signals. I also wanted to make sure that the board was sitting flat on the surface of the PCB, so I used some tape to hold it in place. Now I could flip the board over and start soldering the whole assembly in place. I also needed to solder the 2 wires to the D+ and D- pads. Now I could install all the smaller components in the MIDI circuit and power supply. I used a chip socket for the optocoupler because they're a little bit fragile. Next, I installed the USB jack. Now I started working on the power supply. Notice I installed the regulator bending down a little bit so it wouldn't touch the bottom of the enclosure. I also soldered 2 wires to the plus and minus power terminals. Finally, it was time to install the potentiometers. I designed the footprints so the potentiometers clip in place and hold themselves exactly where they need to be. And then you just need to flip the board over and solder all the pins. I also soldered 2 wires for the MIDI jack, and there you go. The board is done, and the potentiometers are super fun to play with already. Now that the circuit board's complete, we can start drilling out the enclosure. To do this, I go back to Fusion 360 and make a detailed drilling template showing the exact location of all the holes. The Hammond enclosure I'm using for this project is a little tough to work with because the sides of the box are slightly angled. To accurately locate the first hole, I'll center the bit over the outside edges of the box. I can then use the two measurements to accurately locate the center of that first hole. Once that's done, I can reference all the other holes to that first location. I make a second drawing for the back of the enclosure and I locate the bit off of these two edges for that. So here I am at the milling machine ready to drill the top of the enclosure. The two wheels on the milling machine are marked in thousandths of an inch so you can get very precise positioning. I like to tape a paper template to the top of the enclosure, not so much for measurements, but just to make sure I'm not too far off and I didn't miscount somehow. There's a couple of different hole sizes on the top of the enclosure, so I had to change the bit as I went. And here's the finished product. To drill the back of the enclosure, I clamp a vise onto the milling table. The piece of wood is to prevent the enclosure from getting scratched up during this procedure. I'm using a stepped drill bit to help me get the different sizes of holes I need. And here's the finished product. Now it's time to design the front panel graphics. I use Inkscape for all my design work because it's open source, and as you know, I really like free software. I start by placing a number of holes to represent the drill locations we came up with in our Fusion 360 model. Next, I'll add a second set of circles that represent the overall size of the knobs and switches we're going to use, just to make sure they don't interfere with any of the graphics. I then add a rounded rectangle to represent the shape of the top of our enclosure, and this will be the actual perimeter of our graphic label. And then you can just be creative, adding text and graphics until you get a look that you like. And of course, don't forget to add your logo. That's the most important thing. To finish up, I'll place a dark gray border around the box, so when I cut it out, there won't be any white edges. Once I'm happy with the design, I'll print out a high quality copy using matte photo paper. Okay, we are now entering the arts and crafts section of the video. I use a Silhouette Cameo cutting machine to cut out my graphics. The first step is to attach the printout to the Silhouette's carrier sheet. Next, I feed the sheet into the Cameo and let it do its work. When it's all done, I carefully peel the graphics off the sheet. Ah, very nice. I now use a laminator and some 5mm laminating sheets to add a durable coating to my graphics. To attach the panel to the enclosure, I use a product from 3M called 467MP double-sided adhesive. First, I'll mark off a section that's a little bigger than my front panel. Next, I'll grab some scissors and cut it out. Now I'll remove one side of the adhesive and stick it to the back of the panel. I go over it with a roller to make sure it's really stuck. Now I'll use a paper cutter to trim off the excess material. I try to leave a tiny bit of lamination around the edges to keep it from separating from the paper. Now I'll use some scissors to round off the corners. Now for the important part, we're finally going to attach the front panel to the enclosure. Once I have it lined up, I use some tape to create a hinge. The hinge allows me to lift up the panel, remove the back of the adhesive, and stick it down without losing the alignment. I only have one shot at this, so let's hope it works. And once again, I'll use the roller to make sure it's stuck down evenly. All right, I am happy with that. Now I'll just use an X-Acto knife to cut around the edges of the holes. Now we can prepare the circuit board for final assembly. The audio jack assembles from the inside of the enclosure, so I can attach that right now. The other jacks need to attach from the outside, so I'll wait until the board's in place and then solder them together. I'm using stranded wire for all these connections because it's a little more flexible. And here's one of the toggle switches installed. I use stranded wire on these as well. Now we're finally ready to install the circuit board. To start, I installed 4 standoffs to the underside of the enclosure. Now we'll carefully work the circuit board into place. If there were any errors in your drilling, you would painfully find out about it right about now. Luckily, everything seems to fit okay. Now we'll install the MIDI jack. You could use 3mm nuts and bolts for this, but I like to use pop rivets to make it super secure. Once the rivets are in place, I use the rivet tool to fasten them down. I'm using a lot of tape and protection because sometimes the tool will jump when the rivet pops. Here you can see that I've installed the switches, and now I'm coming to my favorite part of the build, which is placing the knobs on the potentiometers. Now you can really start to see what this thing's going to look like. To finish everything off, I'm going to attach some stick-on rubber feet to the bottom of the enclosure and screw it all together. Man, that was a lot of work, but when you see the final result, it all seems worthwhile. So anyways, guys, I hope you found that interesting, and I hope it's going to inspire you to try to make your own version of this project. And like I said, if you do, make sure you send me some pictures because I'd love to see them. And like I said, I am working on a 3D printable version of this enclosure that will hopefully make it a little more accessible for people without a lot of tools. And as always, I'd like to sincerely thank all my patrons for helping me to come up with these cool projects. There's been a couple of new ones since last time, so I hope you see your name on your board. And once again, thank you so much. Make sure you follow Notes and Volts on Twitter, Facebook, Instagram, and Twitch for a behind-the-scenes look at my next projects and all the updates. I'll see you soon.